So in this one, probability of two different houses with two different criteria. For that, we would have to look at the table because the first one is saying greater than 130 meters square. So 130 meters squared is this. Let me clean this for you so you have no difficulty in reading. Okay, so this is for more than 130. You can see we would pick up these two because these two correspond to more than 130. So the frequency of these two is 9 and 7. We are going to add them. So 9 plus 7 is going to be 16, and divided by the total number of houses, that is 80. So this was the first house, right? This was the first house, and you now have to pick up the second house. Okay, do keep in mind that when you are picking up the first house, you have picked up the first house, so now you do not have 80 houses remaining to pick from for the second house. Rather, you just have one house gone, so you just have 79 options. 79 is going to be in the denominator for the second house. And what about the numerator? Let's go back to the table. The required range is 60 meters square or less. So 60 meters squared is right here, or less. So this fits the criteria entirely and perfectly. So 14 should be the one because 14 houses are such which have an area of 60 meters squared or less. They actually have area in between 40 and 60, so that is 60 or less. So 14 will be here. And what about the two fractions? What operation are we going to perform on them? Since this is a question of probability and the two events are independent of each other, so the criteria that we pick up is and, because we have to pick up the first house and the second house. So whenever the word and is there in your sentence, not in the question, but when you talk about for what you are going to find probability, if you want to tell somebody, so you would say I am going to pick first house and second house. You are not going to tell somebody I'm going to pick first house or second house. So definitely it means that you are going to pick first house and second house. So and corresponds to putting a multiplication sign. So you can put a multiplication sign in between and do the rest, leave the rest for calculator. Right, so 16 times 14 and divided by 80, then divided by 79, it gives you 14 over 395 as your final answer, right? Move to question number 3. Okay, so this is a trigonometry based question, and you can see three small triangles right there. So they are joined together. It's a composite figure. ABCDE is a pentagon, right? Calculate AD and show that it rounds to 94.5 meters. So this question is for show. It means you just have to prove and show your answer correct to one decimal place without having to solve. All right, so definitely you would have to show the working of the solution. So let's first find out in which particular triangle this this line AD is. Actually, this line AD is in two triangles, right? So this particular line AD, you can see here, it is falling as a part of two triangles. So I would pick up this particular triangle. Why? Because I have an angle, I have a side, so I can, and I have a right angle as an eligibility. So I can put the trigonometric ratios I'm going to use, right? So let me decide which one I'm going to use. Since I have got 64 degrees and the side opposite to 64 degrees, I'm going to find, right? So the side opposite to 60 degrees, 64 degrees, I'm going to find. So that is my opposite, and the side that I have been given is my adjacent. So I'm going to use TOA. TOA is tan of 64 degrees is equals to opposite, that is AD in this case, over adjacent, that is 46.1. And you can see that I would have to shift it there to multiply. So AD would simply be nothing but the product of 46.1 times tan 64, and that is on the calculator to do. Okay, tan of 64 gives me this, and then multiply by 46.1. So it is giving me 94.5, which is actually what was required of me. So shown, right? Calculate angle BAC in part 2, and BAC is right here, BAC. So you would have to find this particular angle, which is lying in the first triangle to the right. Okay, so this is not a right angle triangle, it's a non-right angle triangle, and it has got an obtuse angle of 94. If I look at this, so 94 degree, and opposite to that a side is provided to me, 78.4 meters. And the angle that I have to find, angle A, opposite to that I have got small a, the side 56.5. So small b is there, small a is there. I think sine of angle A over A. Did you guess what am I using? Right, it's sine rule. Sine rule. So sine of angle A over side A equals sine of angle B over B. And if I plug in the three values, and every time students, out of these four items, three will be provided to you, any one would be missing. That is as simple as that, common sense. So whichever is missing, you can do algebra to find that. But in order to identify whether to apply sine rule or not, you need to look at the triangle like this. So if you have this angle right here, and you have this side opposite, so this is a pair, this is a opposite pair, right? So we have to make pairs of opposite, and if you have this angle and right opposite to this angle you have this side, so this is another pair. One pair would be known, one pair would be entirely known. That means the angle and the side would be entirely known. In this question, this pair of 94 degrees and 78.4 meters is the known pair, is this particular pair, right? But the other pair would be half known, right? So in the other pair you have, in this question, the side given to you but not the angle. The angle is missing. The angle you have to find, right? So if you have to find that angle, so it means out of four items one is missing. This one is missing, sine A, right? So sine A you can go and simply find out. Okay, let's put in the values. Keep the sine A as it is and put in all the remaining values right there. Sine A divided by 56.5 will be equals to sine of 94 degrees divided by 78.4. And you just have to shift this 56.5 to the other side so that you can have your sine A equals sine of 94 times 56.5 divided by 78.4. Put it on the calculator. Sine of 94 multiplied by 56.5 and then divided by 78.4. It is giving me 0.718, but that is not the answer. Keep in mind one thing, common sense tells you the angle cannot be so small. Second thing, you haven't shifted this sign, because the question did not ask you for sine of A, rather they only asked you for the angle A. So angle A is going to be sine inverse of 0.718. So whatever answer you got on the calculator, take out sine inverse of that and you will be good to go. I'm getting 45.96, or if I round it off, so it would become 46 degrees. Right, let's move to part 3. Calculate the largest angle in CAD triangle. So let's look at the triangle CAD and let's clean up the rest of the mess. Okay, so CAD triangle is right here, and that is nothing but this one, right? This particular triangle. So that we have to find the largest angle. Students, keep in mind the largest angle is always opposite to the largest side. How will you find the largest angle? That is another debate. But how would you identify the largest angle? So in that case you would see the lengths of the side. This is 78.4, this is 38.6, and if you remember AD we found out, and even if somebody did not find out correctly, this is mentioned right here in part 1, 94.5. So you can see out of the three this is the largest one, and opposite to this side the angle that I can see is angle C. So angle C is the largest angle which I have to find out. So how am I going to find out an angle of a triangle in which none of the angles is provided to me, but all the three sides are provided to me? The three sides provided to me, 38.6, and then you have, okay, 38.6 is right here, and then you have 78.4 right here, and then you would have 95 94.5 right here. The angle you are going to find is this. So what should I apply? Since this is a non-right angle triangle, there is no right angle mentioned for this particular triangle, so we are going to use cosine rule, because cosine rule does best job when you have three sides and you are looking to finding an angle, right? So let's apply that, and since we are looking for angle C, so that would be cos of angle C equals, you have to square the two legs of the sides. Let me show you what are the two legs. So these are the two legs. This one is first leg of this angle, and this side is the second leg of this angle. So these are the two legs. You have to square them up, both of them, square them up and then add them, square them up and then add them, and then subtract the square of the third side, that is 94.5, and then divide by the product of those two legs. So the legs of the angle, right? Legs of the angle. Which are the legs of the angle? These two, right? So for the question, these are CD and AC. So AD and CD, AC and CD are the two legs of the angle C. Angle C has got two legs. Every angle has got two legs. You need to identify them. And if you can identify them, you are good to go to use the cosine rule. And you have to multiply them in the denominator and also multiply by 2, twice that, like, okay. So the rest is the calculator's job. Do not forget to take the cosine to the other side in the next step, so that you would have cosine inverse of your answer to the previous step. That would give you your final answer. Let me put it on the calculator. 78.4 squared plus 38.6 squared minus 94.5 squared, and divide this whole thing by 2 times 78.4 times 38.6. And then do not forget to take cos inverse of this answer, and that gives me 102.34 as my final answer. I have no space to write my answer, so let me write it here with green. 102.34 degrees, but since the degrees we have to round off to one decimal place, so I would remove the 4 and stick to 3. It's 102.3, right? All right, let's move on. Okay, so let's move on to the next one, and that is question number 3, part B. It has given me two triangles and they are saying that they have got same area, right? So they are having same area. So what am I going to do? If you look at the triangle to the left, you have the legs right there. The legs of the angle are provided to you. Both of the legs are known to you. The same concept that I discussed just now in the previous part, that the two legs of the angle are provided, and that makes it very easy to apply cosine rule as well as the formula for area of a triangle, that is 1 upon 2 times 21.5 multiplied by 27.6 multiplied by sine of 111. This would give me the area of this particular triangle. Since the area of the two triangles are same, so let me equal this to the area of this particular triangle. But how would I find area of this PQR? Since I have only one side available to me, and by the way, what do we need to find out? What are we looking for? We are looking for the shortest distance from R. So a line which we have to start from R and drop that line to the line PQ. So it would be a line, draw a line from R to PQ. So you have to drop that line, right? Rather than just drawing, drop a line from R to PQ, and let's do that together. So from here, it would start going like this. Right, and it would make a right angle. Why it would make a right angle? Because it's written shortest. So shortest is in the meaning of perpendicular. Whenever you have a shortest distance question, so remember you are going to make perpendicular of that. Right. So now it's a right angle triangle, as you can see, and for right angle triangle we use the simpler formula 1 upon 2 into base into height. Base is 34.3, height is what we are actually looking for. Let's call it height h, and let's find it out, because now the formula is complete and only one unknown is there, which is very going to be very easy to find out. The rest is calculator's job. Let me quickly make the mind map of what we have done so far. We have found on the left hand side the area of this obtuse angled triangle, right? And then equated that with the on the right hand side with the area of this right angled triangle. So how it became a right angle triangle? Because we dropped a line from R to the line PQ, and since the question asked us to do a shortest distance, find the shortest distance, so that line that we dropped is definitely going to make a right angle, as is mentioned here, like this. ठीक है? So this is going to make a right angle like this, and you can just complete the line and draw a proper right angle right here. So half into b into h. The two formula are different. This one is 1 upon 2 into ab sine c, and this one is 1 upon 2 into bh. And why the two formula are different? Because of the type of the triangles. One is obtuse angled and the other one is right angled. Right, let's put it on the calculator and do the magic. Okay, so sine of 111 multiplied by 1 upon 2 multiplied by 21.5 and then multiplied by 27.6. Right, this one we have done. Left hand side. Now the right hand side. Okay, on the left hand side I am getting something like this, 276.993, and this is equals to 1 upon 2 into 34.3 into h. I would have to shift both of them there, so it would be definitely 2 would go here and 34.3 would go there, and it would become multiply by 2 and then divide by 34.3. It would give me an answer of 16.15. Is that what you are getting as well? 16.15 is your final answer. Let's write down in green 16, sorry, 16.15 centimeters is the shortest distance from R to the line PQ. That is, this particular line is going to be 16.15 centimeters. Let's move to question number 4.